1.
All right, so we looked at in part 1 how to predict the products of synthesis reactions. So we're going to pick up with our decomposition reactions here and look at how you would handle predicting what the product would be of a decomposition reaction. Now, most of your decomposition reactions require heat, light, or some sort of energy, electricity, to occur. So oftentimes you might see like a triangle written over the yield sign, remember heat added, or you might see the word electricity written over it, something like that. But most decomposition will require heat, light, or electricity. Now remember, decomposition means to decompose, and the definition of a decomposition reaction was when one reactant breaks apart. So our binary compounds that we have here, like made up of just two elements, they're going to break apart into two elements. So just act like you're pulling a puzzle piece apart. You've got hydrogen and oxygen, so you're going to pull it into H plus O. Now, again, you do not want to just blindly bring over subscripts. If you put a subscript on a formula, it will be for a very specific reason. So don't blindly bring over subscripts unless it happens to be a polyatomic ion, and we don't have that here. So anytime you have elements by themselves, this is when you want to ask yourself, is it a halogen, hun? So I told you in the previous video that your halogen huns were your diatomic molecules, and when they're by themselves, there has to be a little subscript too. So all of the halogens and hydrogen, oxygen, and nitrogen are halogen huns. So here we see hydrogen by itself. So is he a halogen hun? Yes, he is. So we're going to put a 2 subscript with hydrogen when he's by himself. Oxygen is also by himself. So is he a halogen hun? Yes, he's the O in hun. So he gets a 2 subscript as well. So your products are going to be H2 plus O2. So this is your skeleton equation for the decomposition of water. Now, you want to go back and balance the equation, of course. So we have 2 oxygens here. I'm sorry, 2 oxygens here. I'm getting ahead of myself. And so I need 2 oxygens here. So I should put a coefficient 2 in front of the water. That gives me 2 oxygens on both sides. This also gives me 4 hydrogens. 2 times 2 is 4. So put a 2 there. That gives you 4 hydrogens. 2, 2, 1 balances that equation. On number 2, we have HgO, so pull it apart into Hg and O. And now ask yourself, is mercury a halogen, hun? And the answer is no, he's not. He's not a halogen, and he's not hydrogen, oxygen, or nitrogen, so you leave him as Hg, the atom. Oxygen is the halogen, hun, so he gets a 2. Now go back and balance it. So I should put a 2 in front of the mercury 2 oxide. That gives me my 2 oxygens. And now I should come over here and put a 2 in front of the mercury. 2, 2, 1 balances that equation. For the next one, silver and oxygen, pull them apart. Pull the silver and pull the oxygen apart, Ag plus O. Once again, you've got elements alone, so ask yourself that very important question. Is silver a halogen, hun? And again, the answer is no for silver. He's not a halogen, hun, so leave him all by himself. Oxygen is, so put a 2. Oxygen is the O in hun. All right, now go back and balance it. We've got 2 oxygens here and only 1 oxygen here. So we should put a 2 in front of the silver oxide, and that gives me 2 oxygens now on both sides. Check out your silvers. 2 times 2 is 4, so we'll put a 4 here. So 2, 4, 1 balances this equation. Go back to number 2. This one would be in its simplest form. 2, 2, 1 is your answer, and here 2, 4, 1. You cannot reduce those. Now, these first 3 were binary compounds, so you just simply pull them apart into their 2 elements. Notice on number 4, I have a tertiary compound. So you have nickel, and you also have the carbonate polyatomic ion. So if you have something that's more complicated than just a binary, I will have to tell you the name of the products. At this stage in our learning of chemistry, we've not learned how to predict to this extent yet. This is just introduction to predicting. So if it's a more complicated molecule, I'm going to give you the name. So let's check this one out. Nickel 2 oxide. So let's practice writing that formula. This is a multivalent metal, so that's why I'm telling you the Roman numeral 2 here, because he can be a +1 or a +2. Nickel can. In this case, he's plus 2. So nickel is going to get a plus 2 charge when you label it. Oxygen, negative 2 charge always. The plus 2 and the minus 2 cancel. So this is your formula for nickel 2 oxide. And then you see carbon dioxide. You see a prefix here, di, which means this is molecular. Carbon is a nonmetal. Oxygen is a nonmetal. So CO2 is your formula for carbon dioxide. Check it out for balancing. 1 nickel, 1 nickel. 1 carbon, 1 carbon. 3 oxygens, 1 here and 2 here. They're both on the same side, so 3 oxygens. This one is already balanced. All right. Let's go on to our combustion reactions. Class, the combustion reactions are the easiest to predict because a complete combustion reaction will always have the same 2 products. You don't even need to think about it. Do not complicate this. Combustion reactions are defined as hydrocarbons burned in the presence of oxygen, and they always form carbon dioxide and water. So don't even try to figure out the formulas, y'all. It's always going to be CO2 plus H2O. CO2 plus H2O. We're going to assume that all of these combustion reactions do go to completion. So carbon dioxide and water. All right, so that's simple. Now the hard part about combustions is balancing them. So I'm going to run back through again with you the trick to balancing them. Remember I said think of Hollister and Company. So you have your order. H is first, then your carbons, then your oxygens. I also kind of shared with you all a trick that I use that works with any combustion reaction. I call it the switch trick. So what you do is you look at your hydrogens. Whatever the subscript of the hydrogen is, that number is what you put in front of the compound on the other side that has hydrogen. So there's a 6 here. So I'm going to put a 6 in front of the water. There's a 2 here as a subscript. So put a 2 in front of your hydrocarbon. You switch them. The 6 goes in front of the water. The 2 goes in front of the hydrocarbon. Now, the next step is to balance your carbons. 2 times 6 is 12. So come over here. We need to put a 12. That gives me 12 carbons here. Do your oxygens last. Okay, I'm going to kind of tally this up underneath. 12 times 2 is 24. 6 times 1 is 6. So 24 plus 6 equals 30. So I got 30 oxygens on this side. So we've got to get 30 oxygens on this side. So what times 2 is 30? That's right, 15. 2, 15, 12, 6. That cannot be reduced. So your final balanced equation coefficients is 2, 15, 12, 6. All right, let's look at the next one. Now, this is kind of tricky, so be careful. This is a little more complicated hydrocarbon. There's a total of 4 hydrogens here, y'all. So normally we just take the 6 and put it here. Well, that's because all the hydrogens are together. So let's look. There's 4 hydrogens. So we're going to put 4 in front of the water. Put a 2 in front of your hydrocarbon. That balances your hydrogens. Now, carbon has 2, so put a 2 in front of your carbon dioxide. Now, tally up your oxygens. 2 times 2 is 4. 4 times 1 is 4. 4 plus 4 is 8. I've got 8 oxygens on this side. Okay, so we got to make this side equal 8. Now be careful. Look, there is an oxygen stuck over here in this hydrocarbon. So we got to figure out how many we have here. We have 2 here. So 2 plus what? Equals 8. There's 8 on this side, so we got to get 8 on this side. Well, this is pretty easy math here. 2 plus 6 is 8, right? Okay, so how can you make this part equal 6? 3 times 2 is 6. So your answer is 2, 3, 2, 4. All right. Again, switch it. Look at your hydrogens first. 12, so we put a 12 here. 2, so we put a 2 here. Now, 6 times 2 is 12. So put a 12 in front of your carbon dioxide. That balances your carbons. Now, oxygens last. 12 times 2 is 24. 12 times 1 is 12. 24 plus 12 gives you a total of 36. I got 36 oxygens on this side. Now be careful again. I've snuck another oxygen in on this hydrocarbon. So 6 times 2 is 12 oxygens here. So 12 plus what? We'll make it equal to 36. 12 plus 24. Okay? So 12 plus 24 is going to give me 36. So I got to get this, the coefficient here, that's going to give me 24 in this spot. So we go 12 times 2 is 24. Now look, 2, 12, 12, 12. That needs to be reduced because you always have to reduce them. So all of them are divisible by 2, 1, 6, 6 and a 6 will balance that equation. Moving on to the last one. There's 16, so put a 16 in front of your water.